Hello everyone. Today we are going to talk about NVDC charger design considerations and trade-off. In this presentation, first we're going to review the battery charger configurations, and then we're going to focus on the NVDC charger design, talking about several things we need to pay attention when we design an NVDC charger. When we're talking about multi-cell battery applications, we're mainly referring to battery configuration 1 cell to 4 cell. Here are just some examples of end equipment in the consumer market with multi-cell battery charging solutions like tablet, some gaming console, power bank, notebooks. And in the industry and medical market, there are some emerging like a POS, walkie-talkie. So all these products may carry different requirement power ratings. So based on the system design requirement, we need to decide what kind of charger configurations will be considered. In the battery charger configurations, typically we talk about 3 types of charger configurations. One is the traditional charger, the second one is a hybrid charger, and the third one is the topic of today, is a narrow VDC charger. First, let's take a quick review on traditional charger and hybrid charger. Traditional charger, we're talking about the input power is typically 65 watts to 130 watts, and the battery input adapter voltage will be from 12 volt to 19 volt. Typically, the battery cell count is 2 to 4 cells. And there's the inductor could be not so low profile, 3 millimeter might be okay. And all the TI solution on the charger side, they are having a requirement to give no smoke under all short conditions. And we do test all our devices to meet those requirements. So here is a topology of the traditional charger operation. When the adapter plugs in, you're going to see the system is directly connected to adapter. And the adapter directly provides the power to the system. And when the adapter is removed, the Q3 battery FET is going to turn on. So the battery pack starts to provide power to the system. So at a single moment, either the adapter or the battery is going to provide the system power. But you don't have a chance to use the power from both sides. When the battery is present, the single path is through Q3. So at that time, the system voltage is equal to the battery voltage. So one of the catalog device for the traditional power configuration is the BQ24725A. So it drives with the N-MOS AC FET and reverse blocking FET drawn here as Q1 and Q2. And its battery FET Q5 is also N-MOS. So by using N-MOS, we can save the customer cost on the total BOM. Now let's look at the hybrid charger. The Intel Chief River platform, they start to promote an idea of turbo mode. The turbo mode really means to maximize the CPU frequency for fast processing. But as the CPU power is getting higher and higher, at the same time, because all the users want to have a smaller and smaller adapter for easy carryover, so that the adapter power might getting reduced. So in order to support turbo power, your system power will exceed adapter power rating. So we are looking for the solution. What is the solution to support the Intel turbo mode today, even with getting smaller and smaller adapter? So then we think about another power source, which in the traditional configuration will never be used with the adapter power, which is the battery. So most of the time, the battery is either being fully charged or partially charged full. So in that case, you have some power in the battery that you never get a chance to use. So here we get the idea of how to do a hybrid charger That means we can use a power from both the adapter and the battery. So to support a system power that is up to 2 times equal to the adapter power. So on the right hand side, this diagram shows how the hybrid mode works. So as the system load starts to increase, I still regulate my adapter current to the rated power. I don't want to overload adapter. And in that case, my charger will detect that the adapter is overloaded and now has to get into regulation. So instead of charging the battery, it reverses the direction of the current and get into the discharge mode. So the discharging current going through the switching MOSFET Q1 and Q2 and reaches the system level, system rail. So it kind of works like a boost converter instead of buck converter. So this is how we get the power from the battery along with the adapter. So similarly, let's just review the topology in the hybrid. That means when adapter is present, you get a chance the current from the battery is either charging or discharging. So there will be a time the adapter and the battery can provide the power to the system at the same time, which is not available in the traditional topology. When adapter is removed, battery now becomes your single power source. So it will still support the system through the battery FET Q3. Please pay attention that the Q3 does not turn on when the device is working in hybrid mode. The power from the battery is getting sent to the system, delivered to the system through the switching MOSFET, not through Q3. So we have the BQ24735 series turbo boost charger or hybrid charger. That is the pin-to-pin and bomb-to-bomb compatible with BQ24725A, our traditional configuration charger. Here you can see I'm still using like 5 pieces of N-MOSFET, and all the inductor, capacitor, and all the bias network stay the same. This can significantly reduce the user's development time, and still they get a new feature to get the power from both the adapter and the battery. So now we talk about NVDC charger. The NVDC charger, for the NVDC charger, the Intel Ultrabook has a definition that's called a new category of notebook that combines the best-in-class performance, has to be ultra thin. So that means it has to reduce the existing notebook's BOM cost and area to make the Ultrabook light, thin, easy to carry around. But meanwhile, we still want a long, same length, same duration of battery life, or even longer. So here, as we can tell, that for the Ultrabook design, still it has to support the Intel CPU platform. So the peak power, 2x peak, can last for about 10 milliseconds. And even with the 30% power, more power than the adapter rating, you have to be able to survive for 50 milliseconds. So here are some requirements from the Ultrabook design, that the CPU power is significantly reduced down to 20 watts, and it has a 20 millimeter thickness. And similarly, the MacBook, it's also similar to the Ultrabook, it has only 70 millimeter in height. And given the thickness of the notebook PC, that means all the inductor has to go below 2.4 millimeter, and it has to be all ceramic. They cannot afford to have a bulky electrolytic cap that will be too thick and consume too much area. So in NVDC charger topology, here is a diagram that's showing, instead of coming the system from the adapter side, now the system is pulled from the battery side. So given that configuration change, you can realize that the system voltage is actually, instead of jumping between the battery voltage and the adapter voltage, it's pretty much limited by the battery range, which for 2-cell battery, it varies only from 9 volts to 12 volts, which is about 3 volt variation. For 2 cell, this variation is even less. It's about 2.5 volts. Compared to the past, you gotta have almost like 12 volts variation for the 2 cell configuration. So this also carries in the name narrow VDC. That means the power supply, DC power supply voltage range is narrow. And also given this NVDC architecture, you can see the adapter and the battery can provide the power to the system at the same time. And now you just have a direct discharging path. You don't even go through a boost converter anymore. On the other hand, when battery is present, it's the only power source, then you still discharge the whole system through the battery. So it's the same, this is the same for the traditional configuration charger, NVDC charger, and the hybrid charger. So we need to think about the benefit and the challenges, because when you're given a system requirement, you need to think about whether the NVDC charger or the hybrid charger is more fit for that design. So let's just compare the NVDC charger with other configurations and see the benefits and challenge. First, let's talk about the benefit you can get with the NVDC configuration. You're going to reduce the number of capacitors in the V-core because you have a lower system bus voltage. So you have a smaller V-core size and smaller capacitors. All these going to save your area and the cost. And also, because now the V-core input, instead of going all the way to 19, it's only going to 12 for 3 cell and 8 volts for 2 cell. That means the efficiency in the V-core is significantly improved. And also you can use a lower RDS on and QG 20 volt rating instead of 30 volt rating because the system voltage change reduction. So these are the benefits that we're going to see with the NVDC structure. And but there are always some limitations. Nothing's perfect. So in this case, all the power that's going to the system will go through charger, while before in the past, for the traditional configuration or the hybrid, you only worry about the charging power going through charger. But now with NVDC, you have to design your charger based on the whole system power requirement instead of only the charging requirement. So this kind of help us set a line that NVDC doesn't seem so attractive when the system power is greater than 65 watts. For the system is below 65, like 40 watts, NVDC still sees its advantage of cost saving and area savings. Even when we realize the benefits and limitations, there are still some challenges we need to face when we design an NVDC charger or system, NVDC system. That means the first is about how we're going to still meet the Energy Star, how we make sure that light load efficiency is acceptable, and also how we deal with the input current DPM transient without overloading the adapter. These two things we're going to talk in the next section, which is going to talk about the design considerations and trade-offs. So we have already released the BQ24715, which is an NVDC charger that supports 2, 3, 4 cell battery configurations. And also we have the BQ24190 family that's gonna support a 1 cell operation.